Low-fat milk. Wow. Para ano? Sa kalusugan. Char! Okay. Now, and then also the third row is with it, which is the situation. Okay, situation. So it's gonna be happening. So, in elastic collision, we need to say, guys, the momentum is conserved. Okay, we need to say, and it's not lost. Okay, get the point? So, like that. So, conserve. Okay, and then the elastic collision also conserve the momentum. Okay, perfectly in elastic collision also conserve, right? Okay, like that. Get the point? So like that. So yes, but for the kinetic energy, elastic collision is also conserved. Okay. We mean of conserve, guys, meaning there's no loss of energy. No loss of energy. Okay? Conserve means no loss of energy. Okay. So for the elastic collision, the kinetic energy, okay, is not conserved. Meaning in elastic collision, it's not conserved, meaning there's a loss of energy. So it could be converted to, let us say, heat energy or sound energy. Okay? For example, if you throw the ball, okay, and then you bump it to the wall, something like that, that's also momentum, right? And then you have the velocity of the ball, something like that. And then it will sound after when you throw the ball and hit the wall. And then by then, when it contact to the wall surface, it will also develop heat. Okay, because constant contact between objects, two objects, especially if you rub it or at a very extreme impact, it will have a heat energy. Okay? Something like that. And now your perfectly collision also not conserved. Okay. So not conserved. In elastic collision, what's the difference? Both of them are not conserved. So here we have gonna be the loss or gain of the kinetic energy. It could either lose the kinetic energy or gain the kinetic energy. Okay, because there's no loss, right? So if there's no loss, meaning it will be losing or gaining, right? And in the perfectly elastic collision, it will have a maximum kinetic energy. So we need to say it's gaining at a maximum, it's not losing for perfectly elastic collision. And then for the situation, when we have the elastic collision, it will bounce off, okay? For example, if you have a table and you contact the two tall, let's say marble. What do you put this one in the billiard? You contact the two ball, okay, it will bounce it hit with each other, something like that. It could either be they repel or they can be going together and move after the impact. Okay, that's meaning of bounce off. And then elastic also bounce off also. Okay, like that. You get the point. It will really bounce. Okay, and then for the perfect elastic collision, it will not bounce off. Instead, it will be sticking together. Sticking together meaning if there is one ball on the left side and another one on the right side, you need to contact that with a force. You apply force, right? It will, with a velocity, it will contact together, and then the two balls will stick together. Okay, it will not separate. Okay, and it will move either side together. So stick together. This is perfectly realistic relation. And this is the most common examples in in physics problem. This one, the perfectly realistic relation. Usually, we are asked to find the final velocity of the objects after collision. It's in here, the most common perfectly realistic collision. But in reality, we don't have this kind of collision. It's only rare. Okay? Because normally, if the two will contact, they will not be magnetized. With the point, unless there is a glue or whatever in reality. Okay, but they will be contacted and stick a little bit together, and they will be separated with a little distance apart with each other. Though it has, but very rare. Okay, in reality, but for the purpose of discussion, it's gonna be like that. Okay, so this topic is common in playing soccer, playing football, playing billiard, basketball, volleyball, anything that has ball. This kind of problem. Okay? But usually the billiard is most common when you do the billiard. Okay? Because the movement is not too fast. It will just be on the table. But if you kick the soccer ball, it will go very, very far. And then it's not easy to compute the velocity in that, okay, compared to the smaller scale setting of a billiard. Okay, you get the point. It's gonna be like that. Now, I already introduced the formula of this problem, like that. Okay, in elastic collision mga palangga, okay, so we will state that aside from no loss of energy, we will treat the momentum 1 is equal to the momentum 2. Okay? And then kinetic energy 1 is equal to kinetic energy 2. With this equation, you can play around of the manipulation of your equations to solve what is being asked in the problem by this principle. Okay? P1 is equal to P2, kinetic energy 1 is equal to K2. 1 is just only a case 1, case 2, like that. Or ball 1, ball 2, something like that. Okay? And then that's gonna be an elastic collision. Okay, but for the, inelastic, it's not like this. Only the P1 and P2. Because the kinetic energy will not be, conserved. So only your momentum is equal to P1 is equal to P2, but not Ke1 is equal to Ke2. Because, okay, there's no loss of energy siya, not conserved siya. Okay? So you need to say, if it is conserved, no losses. Put that in your brain cells. If it is conserved, no losses. And what it means there is the kinetic energy that has been lost or not, gain or lost. Okay? So if it is the value of kinetic energy, okay, there is kinetic energy. It could be either gaining or losing or at maximum level. So that means it is not conserved. Okay? Don't be confused. Okay? So if it is conserved, meaning no loss. Just like you have money, you invest the money. So okay, if it is conserved, meaning to say you did not buy anything, you did not have expenses, you're just keeping your money. So there's no loss of money. To the point, the same story. So that means you save, you conserve. Actually, save and conserve is just the same. Save and conserve. So you have conservation of energy sources, conservation of renewable energy sources, conservation of non-renewable energy sources. So it's just like saying saving renewable energy sources, saving the non-renewable energy sources. So saving and conserving is just the same. Okay, get the point. Okay, muna siya. So conserving meaning saving. Not conserving, there's losses. Okay, get the point. Para masabtan dyan sa conserved. Okay. It's gonna be like this for the theory. Okay, by the way, I found also in the another reference, okay, when I go to Bacala, I researched a little bit with, inelastic collision. I found another formula also, because I love to write a lot, something like that. And then I found out also another equation in which you did not encounter pa siya. Pero when you derive, it's gonna be, you're gonna be having the same equation. It's gonna be like this. I will show you. Okay, it's gonna be like this. if you have two objects moving, or it's going to be like that, and it's going to be v1, initial velocity of the object 1 plus the final velocity of object 1. It's going to be like is equals to the final velocity of object 2, okay, plus the final velocity of the object 2. Okay? Initial velocity of object 1 plus the final velocity of object 1. Initial velocity of object 2 plus the final velocity of object 2. Di ba makalimog siya sa you need to be particular that these one are all object 1. That is all object 2. Okay, so, okay, initial velocity of object 1 plus final velocity of object 1. So that you can really understand, okay, is equal to the, okay, the initial velocity of object 2, v2, plus the final velocity of object 2, v2, like this. It's like an apostrophe. If you don't want apostrophe, just put that as a v1f, because it's still final. But most of the books or references, textbooks, or you can research this in online. So the final, instead of putting small letter f as a subscript in your velocity final, it's an apostrophe like this. That's why I use apostrophe. But like this. Okay? Ganon. Get the point? This is gonna be like this. It's gonna be if the conservation of, the kinetic energy. So kinetic energy is 1/2 m1 v1 raised to the power 2 plus, you need to follow the, the variables and the subscript. 1/2, okay, m1, okay, times v1f raised to the power 2. Okay, like that. 1/2 m2 v2 raised to the power 2, and then 1/2 m2 v2f raised to the power 2. Okay, and if you don't want that one, you need apostrophe, you have to change 1/2 m1 v1 raised to the power 2 plus 1/2 m1 v1 apostrophe raised to the power 2, like that. It's equals to 1/2 m2 v2 raised to the power 2 plus 1/2 m2 v2 apostrophe raised to the power 2. Okay? Ganon. So this is gonna be the equation of kinetic energy, something like that. For it is being conserved, the kinetic energy and the momentum, something like that. Okay? It's gonna be the, okay, this is not for the, perfectly elastic. This is for inelastic, something like that. Get the point? Get the point, mga palangga kumitan. And then the most common formula of inelastic collision also is, this is the most common, guys, because it came out in the board examination. It's gonna be like m1 v1 plus m2 v2 is equal to, okay, n1, okay, ganun siya, and then plus n2 times the velocity final. So velocity final is equals to n1 v1 plus m2 v2 over m1 plus m2. So this is gonna be the perfectly inelastic, as I told you, meaning after hitting or colliding with each other, they stick together. Okay, meaning they will not bounce back when they hit. Sticking together. Take a look, put that in your brain cells. Sticking together. So this is perfectly inelastic. Okay, inelastic. So in here, guys, elastic collision or momentum. In here, as I told you, this is gonna be having a maximum kinetic energy. Okay? Because the kinetic energy is not conserved. Also, perfectly inelastic collision. Okay? Just remember the inelastic collision, or the elastic collision, sorry. The elastic collision, guys, is the other object is moving, the other one is steady. Only put that in your brain cells. Okay? The other one is moving, the other object is moving, the other one is steady, and it hit the other one. So that is elastic collision or momentum. But in the inelastic, mga palangga, so the two are moving with each other, hitting together. Okay? So do not mix, because if you mix, your answer will be wrong. Okay? Something like that. So, we're gonna be having an example na talaga siya. Okay. By the way, guys, this can also be applied for a moving car. Okay, moving car. For example, a moving car or moving east and west, and after that, they collided with each other. Okay? After accident, they collided with each other, and then you are asked to compute the velocity, the final velocity of the two cars when it hit together, because normally when they hit together, they will share the same velocity because they stop and stick together. At the point, their final velocity is just the same when they collide with each other because they are already stopping. At the point, the initial velocity changing, but when they bump or collide during accident, they will have the same momentum or velocity, especially if they hit opposite direction. Okay? The car moving. So we can compute also like that. Okay? And then with the example here, okay? So it's gonna be ganon. So a 5 kilogram block. Okay, but before we start, yes, I need to teach you the technique also for this kind of problems. Could it be projectile, trajectory problem, threefold body, something like that. Okay, force, like this. So the technique here, guys, is we need to consider the Pythagoras theorem. Yes, if, for example, if the direction producing perpendicular direction already, at the point, for example, if car will go to the east and after go to the north or go to the south. So klaro kasi the creation right triangle. At the point. So apply the law of right triangle by Pythagoras theorem dayon. Okay, ganon. So you have the hypotenuse here, like it's like to machuchu, and then sine variable and compute for that. Always follow this. C squared is equals to A squared plus B squared. C is your hypotenuse. The C will be your, for example, final velocity. Ganon. And then final acceleration, or net acceleration, because it's the two one. Okay? And then here also net velocity, like that. So this will be your hypotenuse. Okay? This opposite side is the B and your base is the A. So I'll teach you. Okay? Ganon. Not only that, but also for the tension. Okay, tension for the rope. You get to stretch the rope and you get to pull the rope, something like that. Gamitan mo siya nangyari, guys. So only understand that it can be applicable to, for example, tension is equal to the square root of vertical tension, horizontal tension raised to the power 2 plus Ty raised to the power 2. Okay, this is for tension. Velocity also the same. Velocity is equals to V, okay, like that, V x raised to the power 2 plus Vy raised to the power 2. The component's velocity. We will be dealing the component. Here, component tension, x and y. Here, component velocity, x and y. And we have also the acceleration. Okay? Acceleration, tangential raised to the power 2 plus radial acceleration raised to the power 2. Like that. And also momentum. Momentum is equal to the square root of, let's say, py squared plus px squared, like that. Okay. And also for the distance. Distance is equal to the square root of distance y squared plus distance x squared. So there's a lot of application the same here. If you notice the problem, it will be having a perpendicularity. Meaning to say, go to the east, go to the north, or go to the south. Klaro kayo, mo right triangle. So use this. Okay? And then, in that, you can compute for the angle. For example, car A going to the east, 2 meters per second, and it goes to the south, 4 meters per second. Calculate the angle of the car. Okay, calculate the angle of the car covered. So you are trying to solve for the angle. How much angle that this car are creating after going to the north from the east, something like that. So kay makakreate mo tag mga theta ani. Tangent theta is equal to ganon, di ba? It's equal to the opposite over the base of sine theta, the opposite over the hypotenuse. Cosine is also the base. So, makukompute mo ang angle sa car. Okay? Not necessarily mutuyok siya in a roundabout. Okay? Not necessarily. As long as it will create a triangle. Okay? In here. What I mean, right triangle. I'm not saying obtuse triangle because we have a lot of types of triangle. Obtuse triangle, and we have also the isosceles right triangle. We have also the isosceles triangle. Obtuse, mga ganun siya, acute angle. So only for right triangle. Meaning perpendicular. Okay? There's a vertical, there's also a horizontal. Okay? Di siya ma-apply din siya right triangle. Okay? So that there's a limitation also of the Pythagorean theory. Okay? You get the point. Ganun. So I need to give an example na yung mga tubig na kami ng gatas. Charot! Nangalawa ba? Ay nako. Ganon. So, ito sa ka-problem. Okay. So, here it is. I need to select the most brief and concise problem. Okay. It's gonna be like here. A 5 kilogram charot. Okay. A 5 kilogram block. Okay. Is moving east. Okay. You need to be particular with the direction, huh? You memorize the direction. Okay. Direction going to the right is east, where the sun rises. It's east. And the west, meaning it is on the mountain side. Okay? The mountain side will be opposite of the sunrise, something like that. And after that, the sun will set, sunset. In the mountainous also part. And then the north, it's gonna be like, yes, it's gonna be, the north is in the top, and the south is in the bottom. So you have North Pole and South Pole, like that. So countries and continents that's nearest to the North Pole are having a cold weather compared to the South Pole. You need to say those are, for example, Russia, or let's say Antarctica is very cold because it's in the north, very near to the North Pole, something like that. Okay, it's moving east. Okay, at 6 meters second, like this. Okay, and a 6, what's this guys? And a 6 kilogram block. Like that. Oh my gosh. It's moving north. See? It's moving north. Okay. And then at 4 meters per second. Okay. And then find the magnitude and direction. Nakakaloka. Find magnitude and direction. Actually, it doesn't ask the momentum, but related to the momentum topic, right? Find magnitude and direction. Things like this also, it is also confusing sometimes, right? Because in physical examination, we need to read the exact terminology so that we can compute. Remember? Calculate the force, calculate the pressure, calculate the acceleration. But sometimes there are problems that it will never state literally what's being asked. For example, this one, find the magnitude and direction. What's this? We don't have formula in magnitude. We don't have formula in direction. How can we attack to this kind of problem? But this is easy problem. So things like this also, we don't need to be literal. Okay? You get the point? Magnitude and direction. And then, so relative to x-axis. Relative in reference to the x-axis. Relative to x-axis. So when you say magnitude and direction, so it's very clear that we are having a vector quantity. But still, since we know this is a vector quantity, we don't know really yet what's this all about. Until we need to analyze, there's moving like this, moving, there's a velocity and there's a mass. So what comes in our brain cells, it will be applied the momentum. But you know, not all students having this alertness of the analysis also. Sometimes it will become wrong. Okay? With the point. Because it's not very obvious in the problem what's being asked, right? It's obvious that it's magnitude and direction, but not obvious what's formula to be used. Because the definition of momentum doesn't specify the magnitude and direction there. It says mass times the velocity. And this is magnitude and direction. So sometimes when we start to solve the problem, we found difficulty how to begin with, how to start with, something like that. Because of the terminology, sometimes it is not appearing, or the terminology is not appearing itself in the paragraph of the question. Things like this, see? A 5 kilogram block is moving east at 6 meters per second, and a 6 kilogram block is moving north at 4 meters per second. Find the magnitude and direction relative to x-axis. Right? So many contexts will come in our mind. We need to associate this with the acceleration. We need to associate this to the forces, something like that, right? Get the point that we need to associate this to the 3 laws of motion by Isaac Newton. Get the point? Ganon. And we need to associate also this to kinetic energy, okay, or potential energy, something like that, okay? So in here, we need to analyze that it's moving, meaning velocity, and there's a mass, meaning momentum. Get the point? Anak siya. Okay. Now, so paano ka siya, guys, if you know, if horizontal moving, we need to associate directly the second law of Isaac Newton. Okay, put that in your brain cells also. And then you don't need to go back of how it is being derived. Okay, we need to memorize the finality of the equation at the last, because it will, you know, it will cause you to spend more time if you are on the actual examination and still you derive. You get the point? So that's why you need to memorize completely the appropriate equation to be used. Things like this, the important is you really understand. Okay? So if you really understand, you can analyze it well. Okay? We need to say memorization with understanding. Okay? Because it's not also the same as plainly memorizing without understanding, because it will be lost after 10 minutes, after 15 minutes. But if you memorize with understanding, it will accumulate in your brain cells. It will retain in your memory, something like that. Okay, you get the point? So, it's gonna be like that. So, momentum, P, is equals to mass, change in the velocity. This is the equation of the momentum. Take note, I have the mass as being declared very clear, 5 kilograms, 6 kilograms. Okay, like that. Oh, ganon. Oh. So there's an object 1 and object 2 also. Okay, now the velocity is there, so it's very obvious that we can compute for the momentum. Okay, like that. So find the magnitude and direction relative to x-axis. Okay, now you have to sketch to understand very well. Sketch or illustrate what's happening. It will help you to analyze what's going on in the particular problem. Okay, because it's not easy to solve without understanding the clear picture of the situation, right? It's gonna be like so. 5 kilogram block is moving east. It's gonna be like moving east. It's gonna be east, and this is the block moving to the east. So this is 5 kilograms. Okay, and then at a velocity of 6 meters per second. Meaning this is the V1, meaning the object 1, which is 5 kilogram. Meaning this 5 kilogram is the mass 1 also. Okay. And after that, okay, a 6 kilogram block is moving north, so the north is at the top. Okay, so it will create a right triangle in the north. Okay, the block is 6 kilogram. Okay, another block. Okay, 6 kilogram. Okay, ganon. And then the velocity is 4 meters per second. It's gonna be, let's put this as our M2 and our V2, like that. Now, Can we use the perfectly elastic? We cannot use because they are not they are not colliding with each other. And this is not also hitting the other one, which is at rest. So take note really the restriction of our analysis. We cannot use that. Okay? But still momentum topic. You get the point? So things like this, it creates a triangle, right triangle. So put an imaginary line here and connect the north and the east. So we can produce a hypotenuse. Okay. Your hypotenuse, mga palagaong hitan, is here. Okay, like this. So, if we have the mass 1 with a 5 kilogram, the velocity 1, so this, you're gonna be having your momentum 1 going to the S. Since you're gonna be having your mass 2, 6 kilogram, and the velocity 2, 4 meters per second, so you're gonna be having your momentum 2 here. Okay, so it's gonna be that this hypotenuse here is P, which is equivalent to the hypotenuse of the Pythagorean theory. Okay, now you need to use the Pythagorean theory. P squared is equals to P1 squared plus, okay, P2 squared. Ganon. The momentum in this diagonal line raised to the power 2 is equal to the momentum 1 of the mass 1 traveling to the east raised to the power 2 plus the momentum of the second block going to the north raised to the power 2. In solving to the value of the momentum, okay, in this diagonal line in which you are trying to solve, which is your magnitude and direction. Okay, so it's gonna be like P is equal to square root of your M1 mass 1 times velocity, because this is the definition of the momentum. Raise, okay, like that, raised to the power 2 plus M2 V2 raised to the power 2. Okay. Now check the availability of your data. You have mass 1? I have. Okay, things like this. And if not, you need to solve or formulate another equations. Okay, like that. So mass 1 is I have here 5, and then initial velocity 6 raised to the power 2. Guys, sometimes guys, you don't have to put the units if it's already consistent. Also, try to be alert. If the unit is in meter and in kilogram, then bingo, it's matching. But if it is gram here, it's not matching the meter per second, but because it's not yet a momentum unit. Be careful. It's always kilogram and the pair with the meter per second. For example, if I was saying 5 pounds of one will go to the east, so you need to convert pound first into kilogram to satisfy in putting in your Pythagorean theory. Convert first. But since it's just compatible in the unit, so I am very, very confident to substitute directly in the equation without putting the unit of the individual quantity. Okay, but if it is not compatible to the quantity for the momentum, like for the force, then you have to convert first before substituting that here, right? So we have, okay, so I'm not sure. Okay, kung matug ng tao, ito ko matug. Charot! Okay, so mass 2 is equals to 6, and then V2 na ito mga palang hitan for, okay, raised to the power 2. And the whole thing will be square root. Right? How much is your momentum, the magnitude and direction? So it's gonna be, if it were to put this in a scenario of a distance, this is really the displacement. Okay? Displacement, meaning the final, okay? Final momentum covered between the two directions. Okay? Something like that. Final and initial and final. Okay? Object 1, final object 2, magaganon siya. Okay? So, it's gonna be like that. Char. Ihapay ako bukas. Okay, calculator please. Ganon. Char. So in here guys, we're computing, here is our magnitude. Not yet the direction. Okay. So, 4 times 6 mga palangga raised to the power 2 mga palangga is equals to 576 mga palangga kung kita. Okay, 576. And the other one, okay, we have 36, no, we have 5 times 6, right? Yup. Is equals to raised to the power 2. It's gonna be 900. Okay, here. Okay, 900 plus 576 is square root. Okay, plus 576 square root. How much is this? Kaloka? Yeah. 38.42. So our final momentum is 38.42. 38.42. And this is kilogram meter second. This is the unit of the momentum. This is our magnitude, meaning the value. How about the direction? It's gonna be north, east, south, west, or simply the angle where it goes. Okay? It's gonna be like that. If we try to consider this one, okay, so you need to solve for the angle here. Okay? Like that. This is going there. Okay, so it's gonna be, let's try first tangent theta. Tangent theta is equal to the P2, which we have here, P2 here. Okay, P2 is gonna be having 6 times 4 only because this is mass times velocity only, right? So it's gonna be 6 times 4, 24. This is opposite with the angle, right? And then over hypotenuse, P. And we have our P, which is 38.42. 38.42. That's gonna be tangent theta is equal to arc tangent of 24 divided by 38.42. So this is your angle that your your object will go to the east and later another also will go to the north. So how much siya? Okay. So 24 divided by 38.42 is equals to then arc tangent, shift tangent is equals to 31.9 or 32 degrees. Our angle of inclination is 32 degrees. Meaning, this will go here at 32 degrees and going to the north. Okay? So this is gonna be the direction na talaga siya. Okay? So it's gonna be east of north. Okay, east of north. Because it started with the east, not northeast, right? East of north. Or we say 32 degrees. Okay, the magnitude is 38.42 at 32 degrees east of north. Because direction ng siya. Then if the choices are northeast, like makalibog eh. Northeast is not the same with east of north. And there's no east-north. That's wrong grammar. It's always northeast, southwest, southeast. There's no also west-est, east-west. There's no such like wrong grammar. You get the point? The correct grammar is southeast, northeast, southwest, southeast, like that. Northeast, northwest. But there's no such west-est. Okay? East to west, no like that. You will say like that, east of west. Okay? You get the point? And since there is no also east north, that's why I say east of north. Northeast have, that's correct grammar. But I will say east north, there's no such like that in Webster dictionary. So that's why we need to put of east of north. Okay? You need also to be particular with the grammar of your direction. Okay? But I think the angle is already a clear identification. Okay? But sometimes the choices will also state the angle and will also state the direction. That's a problem. In here, the answer will be 38.42 kilogram per second at 32 degrees east of north. Ganon. Okay? Diba? Ganun siya. Okay, any questions so far? Di ba sa yung graph? Okay, ganun siya. Any questions so far? I hope you like it. My discussion about this momentum topic. Okay, so I don't have time katubo na kayo guys. Okay, taas-taas mo na siyang problem number 2. This will be second, right? This will be tomorrow. Bye-bye, God bless everybody. If you comment down below in the comment section, if you can like, you can share if you want. And share this to physics students. We're students that are taking up physics now. And then you can subscribe to my channel if you like also. And you can click the notification bell for some news updates. And I am a singer, John. Bye-bye, God bless everybody. See you later.